Hey, what's going on, everybody? This is our day two of the 12 Days of Christmas for OpenAI, and we're doing a watch party. We did this yesterday as well. We got Andy, Andy in the car. We got Beth with us, and we did this yesterday. It's pretty straightforward. We're going to find out with you what Sam Altman and the team have to share with us on their day two of their 12 days of OpenAI. They hinted yesterday it'll be something for developers. I don't expect that we're going to get things as big as, O1 and ChatGPT Pro like we did yesterday. But still, it'll be interesting. So we'll listen along with you guys. We'll share it here on the screen, and then we will provide our just 5 minutes, maybe 10 minutes of our thoughts or reactions after they are done with their announcement. So that's what we got going on today. Andy or Beth, any guesses as to what might be coming today?
Well, Jen is saying Andy's on the edge of his car seat waiting for it. There you go.
Can you guys hear me?
Yeah,
Yeah.
we can.
Oh, good. Okay, so I have 5,000 pounds of bass rock in a trailer behind my truck here, and so I'm hauling. And I'm expectant that we're going to see some big drops here. A big dump is going to happen today.
And you're ready for it. I don't know, right? I mean, they started with such a powerful release.
Right.
I mean, I don't think it will match that, but yesterday also can't be the best of what we're gonna get, right?
I think, people like Ethan Malik
Here we go.
know. Yeah, go ahead and open it up. Share it.
Search at OpenAI. Yesterday, we took O1 out of preview and we launched it in ChatGPT.
That sounds really low to me, Beth.
It in the API.
Same.
If you haven't been following O1, it's our latest series of model improvements that allow the models to think for a while before they come back with a response. Today, we're really excited to preview our latest advancement in our model customization program. It'll let users fine-tune O1 on their own datasets. And again, this isn't standard fine-tuning. This is reinforcement fine-tuning, which really leverages the reinforcement learning algorithms that took us from advanced high school level to expert PhD level for your own use cases. I want to stress again that this is a preview of something that we're going to launch publicly next year. But if you are a university or you're a researcher or you're an enterprise, we'll give you some information on how you can access our alpha program later. So why would you want this thing? Well, it allows you to take your golden data sets and turn them into unique offerings that will give you the same magic that we have for your own users and your own customers. So I'll let John, Julie, and Justin.
Golden data sets? Is that what you said?
Hello, everyone. Yeah, my name is John Allen.
I think so. Yeah, it's hard for me to hear on my side.
Hi, everyone. I'm Julie Wong. I'm a researcher here at OpenAI.
I'm Justin Reese. I'm a computational biologist at Berkeley Lab.
Today, we're so excited to be introducing this new way of model customization for our O1 series of models, reinforcement fine-tuning, or RFT for short. For the first time, developers, researchers, and machine learning engineers will be able to use reinforcement learning to create expert models capable of excelling at their specific tasks within their domain. We believe that any field which requires deep expertise in their AI models stands to benefit. So if you work in, say, legal, finance, engineering, insurance, this one's for you. For example, we recently partnered with Thomson Reuters to use reinforcement fine-tuning to fine-tune O1 Mini to be a legal assistant in their co-counsel AI. This tool assists their legal professionals in accomplishing some of their most analytical workflows.
Yeah, so some of you will be familiar with the supervised fine-tuning API that we launched early last year. And supervised fine-tuning is really powerful. What you're trying to do is get the model to replicate features that it finds in input text or images. And this is great if you want to change the tone or the style or the response format of the model. Now, with reinforcement fine-tuning, or reindeer enforcement fine-tuning, as I should say, with reinforcement fine-tuning, it's different. So you're not just teaching the model to mimic its inputs. What you're teaching it to do is to learn to reason in entirely new ways over custom domains. And the way this works is that when the model sees a problem, we give it space to think through the problem, and then we grade the final answer from the model. And then using the power of reinforcement learning, we reinforce lines of thinking that led to correct answers, and we disincentivize lines of thinking that led to incorrect answers. And what you'll see is that, with as little as a few dozen examples, the model will learn to reason in new and effective ways over custom domains.
That's crazy that you can do that with just 12 examples. That's not something you can do with regular fine-tuning.
Yeah, exactly. Yeah, I mean, in the space of large language models and large machine learning, a few dozen examples is basically nothing. Yeah, so for the first time, our model customization platform will support reinforcement learning. And notably, this is the same technique that we use internally at OpenAI to train our frontier models like GPT-4o and the O1 series.
One area with many exciting applications is scientific research. But don't just take our word for it. That's why we're joined today by Justin Rees. Justin is a researcher at Berkeley Lab, and one of his areas of study is using computational methods to understand the genetic causes underlying rare diseases. Justin, thank you so much for being here. Do you mind telling us a little bit more about your research and how reinforcement fine-tuning might help?
Sure, thanks. It's great to be here. So one of the areas of my research is rare genetic disease. So contrary to the name, rare genetic disease is actually not rare. So any one rare disease is rare, but if you put them all together, they're actually quite common. And so we're talking about 300 million people globally who suffer from a rare disease. And what's more, these people often have a long diagnostic odyssey of months to years before they find out about their condition.
Well, it's like the whole population of the US.
Yes, it's not a small number of people. And so what we're working on is better computational tools and methods to really research what's important and help us understand and treat these diseases. So we do our work in kind of an academic setting and learning more about the rare diseases and their causes. And the hope is we'll be able to advance the healthcare for these folks going down the line. And now, assessing rare disease is kind of hard because you kind of have to have two things. You have to have sort of expert domain knowledge about the medical side of things, and you also have to have sort of systematic reasoning over the biomedical data. And this is an area where we think that the O1 model can really help us out with its reasoning capabilities.
That makes a lot of sense. Our large language models have domain knowledge, and our O1 models are really systemic reasoners. So it seems like now there's a pretty good computational method for addressing some of these.
That's right.
Can you tell us a little bit more about the data sets that you're using?
Sure. So this was sort of a collaborative effort between our group and Charité Hospital in Germany and Peter Robinson's lab and the Monarch Initiative. And what we did really was to extract disease information from hundreds of scientific publications that were case reports about rare disease. And so we sort of curated the information, and that's lists of signs and symptoms that were present in the patient and that were excluded in the patient, and then of course the disease that they had, and importantly for this conversation, the causative gene that was mutated that was causing the problems in these folks.
I see. So you and maybe some doctors are trying to figure out, given a patient's symptoms, what gene might have mutated to cause those symptoms.
Yeah, that's right. And so something we've been working on together with the OpenAI team is training the O1 models to reason more effectively about the causes of disease.
Incredible. Thank you, Justin. We're now going to give you a preview of reinforcement fine-tuning at work. And not to steal any thunder, but we're going to take O1 Mini and make it exceed the performance of O1 on this task.
I think they should have used O1 for a better
this
script.
This matters so much because O1 Mini is a smaller, faster, and cheaper model than O1.
Yeah, so using Justin's data set, we're going to show you can just drastically improve the performance of O1 Mini on this task where, given a list of symptoms, you're trying to predict which gene might be responsible for the genetic disease. And so to give an overview of this process, we're going to start by looking at data sets that are used to train the model and graders that are used to evaluate the model. And then we're going to launch a training job on OpenAI's training infrastructure. And finally, we'll evaluate the resulting fine-tuned model so we can see how it's improved over the base model that we started with. So to start us off, we're going to jump over to the OpenAI development platform, and we're going to go ahead and we're going to create a new model. So,
are they doing this live?
We've had
Like, is
supervised
this a
fine-tuning for a bit over
5-minute
a year
thing?
now. What we're going to do is we're going to select
don't know.
reinforcement fine-tuning. Now,
That'd be pretty
we're gonna
cool if
use
it is.
Training O1, so we'll select that as the base model. And now we need to upload a training data set. And now training data sets, they're just JSON-L files, which is just a file where each line in the file is an example that you want the model to be trained on. For this case, Justin and his colleagues assembled a data set of about 1,100 examples.
Wow.
And so we'll go ahead and upload that one. And just so that we get a really good feel for how this data set works and what this task is, we'll zoom in on an individual data point really quickly. And so this is what an individual data point looks like. And there's really three important things here. So The first is the case report, and this is a description of the patient and the patient's symptoms. So we see that the patient was a 51-year-old woman, the disease onset was not specified. We have a list of symptoms like hypertelorism, hyperparathyroidism, and others. As Justin said earlier, we have the absent symptoms. These are the symptoms that are not present, and this is important because it helps the model to rule out genes that it might think would otherwise be responsible for these symptoms that are present. Next, we have the instructions, and I'm sure if you're watching this live stream, you're familiar with prompting. And so all we're doing here is just prompting the model for what we want it to do for this task. And so what we're saying is, given the list of symptoms and the case report, can you list all the genes that you think might be responsible for the genetic disease that you think is present? And then we also ask it to provide an explanation for why it thinks those genes might be responsible. Finally, we also have the correct.
It's good to see that this is prompting 101, right, Beth?
Is responsible, but
Right. And
we're
this
not
is the
showing
golden
to the model
data,
during the
right? The
training process.
golden
That would be
data means
cheating, but
super
we're using
specific.
it internally during the training process to grade the model's outputs or to check if the model's correct.
That's my assumption.
This is a pretty hard task. I definitely have no hope of answering this question.
Yeah, I mean, you can tell that we've come up far away from just trying to count the number of R's in the word strawberry. Yeah. So,
yeah, maybe.
So now when we give the model
Like that they all laughed at that.
this case report and these instructions, the model's going to output something like this, which is a list of genes that it thinks might be responsible. And importantly, the genes are in sorted order, where the first gene in the list is the one that it thinks is most likely to be responsible, the second one in the list is the one that it thinks is second most likely, and so on and so forth. Cool. So we'll hop back over. And so next we need to upload some validation data. And validation data, it's going to be in the exact same format as the training data. But importantly, there's no overlap in the correct genes between the validation data set and the training data set. And what that means is that the model can't cheat. It has to, or it can't learn to just memorize a list of symptoms and associate those with the genes. It has to actually generalize from the training data set to the validation data set.
Gotcha. So, I mean, where's the reinforcement part come in? We talked about grading. Is that part of the process here?
Yeah, that's a really good question. So grading is done by this concept of graders that we're introducing here. And so graders are really simple. What a grader does is it takes the output from the model, and it takes the correct answer, and it compares them, and it returns a score between 0 and 1. And so 0 means that the model did not get the answer correct at all, and 1 means the model got the answer correct. And you can also give partial credit, so it can be anywhere in that range. So for this specific task, we have a grader that looks like this. So it takes the correct answer that we happen to know, and it takes the output from the model, which is the list of genes, and it produces a score. So in this case, FOXY3 is the correct answer. It was second in the list of genes, and so it gets a score of like 0.7.
I see. So if it had instead said Foxy3 was first in the list, I would have gotten a grade of 1?
Yeah, exactly. Nice. And then as it gets further and further along the list, the score kind of gradually decays to 0.
Ah, nice. Makes sense. But what if I have a task that isn't, grading a ranked list? Do we have other graders that are more general?
Yeah. So we're supplying kind of a collection of graders that we think pretty effectively cover the space of possible intents that you might have for while doing reinforcement fine-tuning, and we're always adding more.
Yeah, and eventually we're gonna hopefully let you define your own graders.
Yeah, maybe like upload a Python file or something and do some custom grading. Yeah. Cool. So we've defined our training data set. We've defined our validation data set. Let me go ahead and copy in the grader really quick. And now OpenAI allows you to set, we allow you to customize these fine-tuning runs by setting hyperparameters, but we set some pretty good defaults. So I'm just going to go ahead and click Create here. Now, what this is doing is, we've just kicked off a training job. And so the really cool thing is that you bring the data set and you bring the grader.
I love
and
seeing that that's a live date
you really
and
have
timeline,
domain
right,
expertise
Beth?
and where you can really
That's
contribute
huge.
to this problem. And then you get to leverage the full power of OpenAI's reinforcement learning algorithms and our full distributed model training stack to customize a frontier model for your use case.
So as a user, I just have to bring my data set and the grader, and OpenAI takes care of everything else.
Yeah, exactly. Yeah. Reinforcement fine-tuning jobs can take anywhere from a few hours to a few days to run. So we're going to jump over to a job that I ran earlier this week on the same data set, just so we can kind of see the results.
That makes more sense.
So I'll jump over here.
Yeah.
So I had this job that I ran earlier this week. It completed successfully. It produced a fine-tuned model for us. And there's one thing that I want to look at, which is the validation reward score. And so what this is it's the average score from the grader on the validation data set and how it changed over the course of the fine-tuning run. And so what we can see is that the score is going up. And as we said earlier, since there's no overlap in genes between the training data set and the validation data set, it means that the model really learned to generalize on our task. It wasn't simply memorizing a list of symptoms and mapping those to genes. So, while this is cool, the chart goes up and to the right, which is what we like to see, it'd be nice if we could get a better feel for how the model has actually changed during the fine-tuning process. And so, we'll take a closer look at that now.
All right, so we're going to pop over to the evaluations dashboard, which is a product in our developer platform that we launched earlier this year. There's a lot of numbers, but don't worry, we're going to go through all of them. So I've set up 3 different runs here. The first one was a run against our O1 model, which we released yesterday. The second was against O1 Mini, which was the starting point of our fine-tuning job. And then finally, the reinforcement fine-tuned O1 Mini. Now, we looked at the reward going up and to the right, but what does that actually mean for this task? I've set up 3 different evaluations to sort of assess that. The first one is top at 1, which is how often is the correct answer the very first item in the list. Top at 5, which is how often is the correct answer in the top 5 elements of the list. And finally, top at max, did we at all put the right answer in our list? And so looking at top at 1, we can see that our starting point, O1 Mini, got 17%. On our data set of about 200. O1 got 25%, so it's doing better. But then our fine-tuned O1 Mini got 31%.
Awesome.
I took a screenshot of this and I put it into ChatGPT and asked it to make me a plot, a Christmas-themed plot. And here's a nice visualization of those 9 numbers that we saw earlier. So you can see our starting point, O1 Mini, across top at 1, top at 5, and top at max. Our O1 model, and then finally, our best performing model, which is this O1 Mini fine-tune here in dotted red line. So looking at these results, what do you think, Justin?
Well, I think this is pretty impressive performance, and especially the increase in the validation data, because that implies that the model is learning something generally about how to reason over these kind of data, which is pretty exciting. And so an obvious question you might ask is, how is this doing compared to existing bioinformatics tools? And I don't really have an apples-to-apples comparison, but because typically in this kind of experiment you would provide genomic sequencing data, and we haven't included that here. But the sort of open-ended querying of models here over incomplete symptom lists is new and exciting, I think.
Great. So these are aggregate statistics, but let's look at the actual model responses. So I'm going to pop on over to this data tab. Let's filter by the passes. And so here is the input that we're giving to the model. So the problem, as John described earlier, is to identify genes that may be responsible for a set of observed symptoms. We asked the model to output a dictionary containing both a string that explains, why did I pick these genes, and of course the genes themselves in ranked order. And then finally, we have the symptom list as well. So this patient presented with subependymal nodules, seizure, and a couple other things. We then run our
That's
model.
exactly what I would have done. Yeah, some other stuff too.
This was our fine-tuned O1 Mini model. We gave it that input, and now the output is this dictionary that we described earlier. So reasoning, the combination of subependymal nodules, seizure, cortical tubulars are indicative of this complex, which is commonly caused by mutations.
So the structure we're looking at
in
is
these genes.
JSON. If you hear people talking about JSON, that's what this looks like.
And then it says TSC2 is the most likely candidate. And if we scroll back on over to our answer, we'll see that TSC2 is in fact the correct answer. So that allowed us to get a pass on top at 1, top at 5, and top at max. So looking at this output, Justin, is this a useful output for the model to be giving back?
Yeah, absolutely. So it's particularly useful to see the model's reasoning, and that's a big contribution here. And also obviously the ranked list of answers. So even if the correct answer is not first, you can look at all the possibilities. And it's also great to see the fine tuning improves the performance in the ranked list of possible answers, so that right answer is getting closer to 1. So that's gratifying.
Justin, kind of zooming out a little bit, how does reinforcement learning shape your field? Can you talk about some trends in biology?
Sure. So I think there's a lot of interest in the research community in using these models for these kind of tasks. And so the feeling for this particular use case is that the best solution in the near term is probably a hybrid solution between existing bioinformatic tools and these models like O1. And so this, I think, is excellent progress in sort of characterizing the strengths of these models and also how we can use tools like fine-tuning to improve performance. And so, like I said, there's not really a comparable benchmark to compare the two, but it's definitely progress in how we can use these models to kind of understand disease. And then, in a larger sense, to sort of how we can incorporate these models into a workflow that will eventually improve healthcare for these folks.
Right.
Amazing. Thank you, Justin. So while we've just shown you an exciting application of reinforcement fine-tuning in scientific research, this is a general purpose technique. We've seen promising results in data sets from biochem, from AI safety, from legal, and from healthcare as well. We can think of hundreds of more examples or tasks that we can use this model on, but we know that you can probably think of many more. So that's why we're so excited to be expanding our Alpha program today to enable more people to push the boundaries of the capabilities of our O1 models on the tasks that matter the most to them.
Yeah, so we've been working with a small group of trusted partners to really test out reinforcement fine-tuning. And today we're expanding alpha access via what we're calling the Reinforcement Fine-Tuning Research Program. So this program is ideal for organizations who are currently working on very complex tasks with teams of experts and who think that they might benefit from AI assistance on these tasks. So if you're interested in applying for one of these limited spots, you can find a link to the application in the description of this live stream. And as Mark said earlier, we plan on launching this product, Reinforcement Fine-Tuning, publicly early next year.
Yeah, we're all really, truly excited to see what you do with reinforcement fine-tuning. And really speaking as a researcher, there's nothing that makes us happier than seeing our models being adapted and used to advance science knowledge in the real world. Do you have a joke for us today?
Well, as so happens, I do. As it's become tradition, I have a Christmas-themed joke. So, we live in San Francisco.
A tradition since yesterday.
Vehicles are all the rage. Okay. And actually, Santa's been trying to get in on this, too. He's trying to make a self-driving sleigh, but for some reason, his models just keep not identifying trees, and the sleigh is hitting trees left and right. Do you guys have any guesses why?
No.
He didn't fine-tune his models.
Oh, geez. Okay, all right. Please join us next week. We'll have a lot more to share. Thank you.
Okay.
I do like that they decided to do that. Okay, let me reset the room here so we can use this as a different video. So, all right, guys. So Beth, Andy, we just heard from OpenAI, and this is day 2 of their 12 days of OpenAI. And today was sort of a continuation of yesterday's when they released O1 out of the preview, as well as something else they talked about, ChatGPT Pro. But for now, let's focus on O1, because what they just said today, and we got the answer right at the end, which is like, kind of, where is this right now? They said it's in alpha. And maybe even before that, there was just a few partners that they were working with to do this. So this is reinforcement fine-tuning, RFT is what they were referring to it. They said they're excited for it to launch publicly early next year. They added that at the end as well. And they also talked about, for this alpha program that is going to be released out to people who apply, there's going to be application process, and they call that the RFT research program. And for educational, universities or other research groups that might feel like they can come up with 100 new ideas, like they were just saying, they would be able to get access potentially. They said there'd be limited spots potentially before this goes public. So we had a lot of people joining us live today, which is awesome. And some of the questions came up right away, which is like, so this is just a preview of something that's coming out next year. Well, sort of, for the vast majority of us. But what I think it's really cool, and I'd love to get your guys' quick feedback on this, just these are our live thoughts on this, is that this is really showing where the potential impact in areas like healthcare, finance, and other areas, I mean, education, holy moly, can be with a powerful model. They said it yesterday that the O1 models are the most powerful models out there, as opposed to your like GPT-4o type models, whatever. The O1s are more powerful. So this is interesting to me. I mean, this is like one of those things, like, it's not a toy I can play with, but I'm just super glad that the right people are going to be able to play with this toy. Like, I can't wait to hear what they have to say, or I can't wait to talk about this on a Wednesday when we do our news show. What was your initial feedback, Beth or Andy?
Yeah, I would like to just mention that training LLMs to, produce outputs is a well-known process. And what we saw here is a demonstration of taking a very advanced reasoning model and training it on specific domain deductive reasoning. So it's getting information and it's having to then apply its reasoning skills. And the grading part of this platform that they've developed is dependent on the supply of a set of training examples where the answer is known. So the person who was there in the room from Berkeley, that person actually contributed significantly. Actually, the heavy lifting wasn't in giving new training examples to the model that already knows how to reason, but it was somebody developing a training set that's in addition. It's a fine-tuning training set, not the original pre-training data set, but it's a fine-tuning data set. And so I think that what that does is it limits the usefulness of this to a select group of high-end research kinds of applications where you can actually generate that. And that, while the actual demo or fine tuning of O1 might only take days, preparing the examples and making sure that the data is right and that the correct answer is in those where it's sometimes ambiguous what the correct answer is, that's hard. That's the heavy lifting here. So if you have a company or you have a domain of knowledge where you can generate such a thing, just know that OpenAI is waiting for you to use their most advanced reasoning model to do fine tuning of that and get to a really competent thing. But there's also open source models out there that could be fine tuned in the same way. The same kind of pipeline could be done. And OpenAI though has done a nice thing, I think, which is to build a pipeline for that process for anybody who wants to use the O1 model.
Right. I think what we've seen here is what they've been talking about for a while, which is that we're going to see ASI before we're going to see AGI. And this ASI meaning artificial super intelligence, meaning it's smarter than humans in a particular narrow way, versus artificial general intelligence, where it's smarter than humans in all of the ways that you can generalize about. And I think you're right, Andy, that this is for that the people who will use this first will be in research labs who already have that kind of data set because they're working that way. But they said that there are custom graders, right? Like it does not have to be that. If you, in the example that they gave, if you have a data set where there is some information and one right and many wrong answers, that's a data set that could be used in this. So I think that broadens it out. Yeah, Brian, you're going to push back.
I am. I'm going to push back a little bit because I don't think that's the only place you're going to see this. Now, costs may be prohibitive, so we don't know the cost yet. Somebody was saying in the comments, "Well, is this just going to be part of the Pro, the $200 a month that they announced yesterday?" Don't know the answer to that. They didn't mention that today. However, if we put aside cost prohibitive side of it and say that this is generally available, I think you're going to see this used by teachers almost immediately, because that's an area where you have teachers every single day across the world. I mean, certainly in the States, but across the world, who are doing grading, who are using some sort of matrix where there are definitive right and wrong answers. It's not creative writing. There's like actual right and wrong answers. They have mountains of data that they could probably put together fairly quickly or with limited uplift to create what you were saying, Andy, the hard work, which is the actual training of what is actually right and wrong. And I think you will either see this, you will see some really innovative teachers who see this as a amazing potential for them personally. But I think in short order, you will start to see entire school districts start to employ this. If maybe not, what I think it's going to happen. It's going to be like a history teacher. Definitive right, wrong answers. This happened on this date or didn't happen on this date, right? That's an easy thing to train on. And a lot of that history might already be in the data set, right? But maybe there's some reinforcement, fine tuning that needs to happen because of whatever the reason was for that. Okay. So it might be somebody who's really interested. Then the history department says, wow, that's really helpful. That just took a huge lift off of our already burdened teachers who are having to do this repetitive manual process of grading. And oh boy, now they just have to monitor the system and not do it. And I think very quickly you see this trickle up. So it's going from the teacher to the department to the school to the district. And I think
so
this
I'm
could
going to
potentially
push
be the
back
end
on
of
that.
grading.
I'm going to push back a little bit on that, Brian, because the example that you used, history, does not require reasoning. You don't need to reason on the facts of history, right? There is a correct answer. So it's not deductive reasoning. Okay, so give me an example of something that happened in the past about the facts about which we know that requires a reasoning approach rather than a recollection approach.
Compare and contrast the events of this and that are known facts, and explain with critical thinking why these two events in history that have nothing to do with each other are similar and dissimilar. I think there's a reasoning that would go into that if you used O1 to get an answer, but there's probably a matrix-like answer that would come to that that's based off the facts of history. So that would be my first guess.
Yeah, so I think that there probably would be an advantage from a reasoning trained model's perspective to, if we did O1 on that question, compare and contrast, it would probably perform better than 4.0, just because its reasoning capabilities are better. But and part of the reasoning has to come from interpretation of what your request is, right? I need to figure out a plan to address this question, and that's the thinking that goes on behind the scenes before the response is generated. But I still think that fine-tuning a model for that purpose may not be as beneficial. I think I might get the same output because of the existing historical knowledge of the O1 original pre-training set. I might get something very similar there, and the fine-tuning wouldn't really give me the same advances that I would get from the complex reasoning required for sort of genetic diagnoses.
And that's because you don't live in Florida, Andy. And in Florida, there could be a desire to reinforce and fine-tune historical events. I shouldn't say that. I live here. I love Florida, home state. I've been here for many years, but you're allowed to poke it at the places you live. And so that's my poke. No, I mean, hopefully that's for nefarious reasons, right? We hope we don't see that. But I see your point. I see your point that, like, what is this something that would require the reinforcement fine-tuning aspect of O1? You're probably right. Maybe history was a poor subject to go into. Regardless, I do see this being valuable in education. And I guess my initial point, even though you're correct to say it's sort of a poor example of that, but just in general in education, you guys are kind of saying like, oh, this might just be like research labs. And I guess my initial pushback was, no, I actually could see people using this, assuming that the cost is not prohibitive. I could see people actually tinkering and using this and trying to get, I mean, we saw with their example, it was a difference of 38%, or at one was went from 38 to 43. It wasn't like 38 to 79%, achievement. So like we're talking about incremental improvements, even with the data set that they used in that example, which I kind of love because they didn't make it out to be this like amazing, gonna solve all. You even heard the expert from Berkeley say, I think used as a hybrid in combination with our other, and he used a technical term, tools,
bioinformatics,
that this could be very helpful to us. It's just another tool for us to use. But he said it himself. It's not a replacement, certainly not at this point, for the procedure the way they do it right now. So anyway, that's my thing. Look, I'm excited for the right people to have this. It's not going to be me. I probably will have no need for it. I barely can think of ways to use O1 a lot of times. So reinforcement fine-tuning O1 is probably not going to be for me, but this is very exciting to see this, because I think we'll all learn. And again, the guy from Berkeley said it as well, that it's helpful to see the reasoning that it went through, the model went through to a tribe. And that is so valuable. And I think we'll all be able to learn from that reasoning, right, Beth?
Right, because when the tools are reasoning, they're actually leaving. They tend not to, like, you have to click on it to see the reasoning pattern that they're showing. But it's so interesting to see the processes that they're going through in order to reach the conclusion that they're reaching. Because finding the wrong answer is, for a researcher, as instructive as finding the right answer. Right, all of it is data.
Yep.
The other thing that I find really exciting about this, and I'm always like, this is a lovely present, and what else could be great? So I'm gonna say this is a lovely present, but I can't wait until it's multimodal, because now it starts to get to the fine tune of being able to see things on a scan, and we've already seen that there's so much advancement in it. Right, because it's able to discern, just visually, it's able to discern at a much finer level than a human. But now, what are the patterns that we're able to determine based on like using that? And now, can we create a golden fine-tuned model that can give people answers?
That's a great example, because what happens with AI interpretation of medical imaging is that it gets things that a human reviewer isn't focusing on, and determines correlations between elements of the scan that we can't even perceive. And so it requires some reasoning to determine what actually is interrelated here in this image, that humans are focused on one thing. Is there a tumor in this image or not? That's classification in AI. Does this match a tumor model or no? That's a binary kind of decision. But looking at a scan and thinking about it in a holistic kind of health scan kind of way would require advanced reasoning. And you'd want to train it on examples that have like little indicators that the normal radiologist wouldn't be looking at, that would actually be informative about some correlated or uncorrelated disease that's being represented in the image.
Yeah, I love that. And I think we'll end on this, I guess, unless you guys have anything else to add, because we do try to keep these short as far as just our initial thoughts, reactions. Like we heard it with you guys. So this is where our brains are on it right now. We can't wait to hear more from what you guys, anybody that's listening, I said, what you think about it. Certainly put it in the comments after this video goes out. What I was going to say is, from a hopeful standpoint, like I was saying, I'm excited about this getting into the hands of people. And I'll just tell you a quick personal story. I've mentioned before that my mom passed, I believe, on the show. My mom passed in 2008 from cancer, and they would still qualify it as breast cancer, but that's because the initial diagnosis 6 years prior was breast cancer, although not necessarily what my mom ultimately passed from. It was a spread of cancer. Anyway, the reason I bring it up is not to be a downer, but is actually to repeat something my mom said. Let's see, this would be around 2002. And she said, when she initially beat the first round of cancer, because she actually did go into remission, she said, Brian, my goal is to outlast long enough. I truly believe there's a solution. There's a cure for cancer. And I said, I'm with you. And sadly, she didn't outlast, at least for her particular diagnosis. Of course, there's many different types of cancer. And she passed in 2008. But I have to say with a lot of confidence that if we fast forwarded to today, December 6th of 2024, and my mom was in this same position, and she was saying she beat the first round, I would have to say I feel very confident that she would actually be right today. And I think that's because of what we're seeing coming out of these language models, what we're coming out of this AI assistance of our truly best of the best when it's in medical and other areas. And yesterday when they were talking about the proteins, and gosh, so much of it is over my head. I just try to keep up like everybody else and everything. But I go, isn't this amazing that this is going to be in the hands of some of the smartest and brightest people we have around the world? And hopefully if they want to use this, they'll be able to use this as much as they want to solve big problems. And, you know, maybe, just maybe that means 6 years from now, we have in fact cured diseases that had previously been untouchable. And so it's really, really exciting to me. I love these types of, announcements. It makes me excited for the future for sure. Okay. Anything else from you guys before we wrap it up?
Join us Monday. We've got great shows. If you just learned of us here, we do a live stream Monday through Friday from at 10 a.m. Eastern, 7 a.m. Pacific, different AI topic each day. And so on Monday, we'll be here at 10 a.m. Eastern, 7 a.m. Pacific, and then again at 1 p.m. for the day 3 drop because they're taking the weekend off.
That's what I was just about to ask you. I was going to confirm with you that because you told me that, I didn't realize that. So we will not have a day 3 tomorrow. It'll be Monday before we have day 3 of the 12 days of OpenAI. So come back and enjoy us all week. And then obviously at the 1 o'clock to catch up with whatever they're going to announce next. So far, I think they're 2 for 2 and the dad jokes to end it on. So I guess they're going to have to keep doing that.
I'm here for the dad jokes. I
That's
want
what
them.
somebody else said in the comments too.
Yeah. I want them worse and worse each time, and I feel like they're starting to really hit that target. All right, thanks everybody.
See you guys.